Top 20 Graph Neural Networks, GNNs, Interview Questions. Question 1. What is the main purpose of a graph neural network? A. To analyze sequences of data. B. To model structured data as graphs. C. To enhance image classification tasks. D. To predict sequential outcomes. The correct answer is B. To model structured data as graphs. GNNs are designed to operate on graph-structured data. Question 2. What is a node feature in a graph? A. Information attached to the edges. B. Data representing graph structure. C. Information associated with graph nodes. D. Data representing the entire graph. The correct answer is C. Information associated with graph nodes. Node features represent attributes of nodes in the graph. Question 3. What is the main function of the message passing mechanism in GNNs? A. To reduce the size of the graph. B. To update node representations by aggregating neighbors' information. C. To categorize nodes based on their features. D. To perform graph clustering. The correct answer is B. To update node representations by aggregating neighbors' information. Message passing allows nodes to update based on neighboring nodes' data. Question 4. Which of these is a limitation of traditional neural networks for graph data? A. They cannot handle unstructured data. B. They cannot process sequential data. C. They cannot effectively handle graph-structured data. D. They can only process vector data. The correct answer is C. They cannot effectively handle graph-structured data. Traditional networks are not designed to process graph structures. Question 5. What does the term graph convolution refer to? A. Applying convolutional layers directly to graph nodes. B. A method for pooling graph data. C. Aggregating neighbors' features for a node update. D. A technique for simplifying graph connections. The correct answer is C. Aggregating neighbors' features for a node update. Graph convolution updates a node by aggregating features from neighbors. Question 6. What is the key advantage of using graph attention networks? A. They simplify graph structure. B. They allow nodes to focus on important neighbors. C. They remove redundant edges in graphs. D. They improve node clustering efficiency. The correct answer is B. They allow nodes to focus on important neighbors. GAT uses attention mechanisms to weigh neighbors' contributions. Question 7. What does neighborhood aggregation refer to in GNNs? A. Grouping nodes based on their features. B. Updating node features using neighboring nodes' information. C. Reducing the graph's size. D. Selecting the most relevant edges. The correct answer is B. Updating node features using neighboring nodes' information. Neighborhood aggregation enables information exchange between neighboring nodes. Question 8. What is the purpose of pooling layers in GNNs? A. To reduce the graph size. B. To extract hierarchical graph features. C. To increase the dimensionality of node features. D. To improve message passing efficiency. The correct answer is B. To extract hierarchical graph features. Pooling layers help in extracting more abstract representations of graphs. Question 9. In GNNs, what is oversmoothing? A. When node features become too distinct from each other. B. When node features become indistinguishable after many iterations. C. When nodes are overly connected in the graph. D. When the graph becomes too large to process. The correct answer is B. When node features become indistinguishable after many iterations. Oversmoothing occurs when repeated aggregation leads to indistinguishable node features. Question 10. What is a typical application of graph neural networks? A. Time series prediction. B. Recommender systems for item ranking. C. Image segmentation. D. Predicting the next word in a sentence. The correct answer is B. Recommender systems for item ranking. GNNs are widely used in recommendation systems to analyze user-item interactions. Question 11. Which type of graph does a GNN typically operate on? A. Sequential graphs. B. Dynamic graphs. C. Static, unstructured graphs. D. Only fully connected graphs. The correct answer is C. Static, unstructured graphs. GNNs are often applied to static, unstructured graphs with rich node, edge features. Question 12. What is graph isomorphism in the context of GNNs? A. Mapping graphs onto a common scale. B. Ensuring graphs are exactly identical in structure. C. Learning to match graphs with similar properties. D. Transforming graphs into a vector representation. The correct answer is B. Ensuring graphs are exactly identical in structure. Graph isomorphism refers to determining if two graphs are structurally identical. Question 13. What is the role of edge features in GNNs? A. They provide additional information for nodes. B. They connect nodes in the graph. C. They update node representations. D. They are not used in GNNs. The correct answer is A. They provide additional information for nodes. Edge features provide contextual information between connected nodes. Question 14. What is the main challenge in scaling GNNs to large graphs? A. Insufficient memory to process large graphs. B. Difficulty in graph convolutions with large numbers of nodes. C. Overfitting due to too many graph features. D. Limited model interpretability with large graphs. The correct answer is B. Difficulty in graph convolutions with large numbers of nodes. Large graphs result in computational challenges during the convolution operation. Question 15. What is graph pooling used for in GNNs? A. Reducing the graph size for faster computations. B. Simplifying graph structure while retaining information. C. Combining all nodes into a single representation. D. Eliminating unimportant edges in the graph. The correct answer is B. Simplifying graph structure while retaining information. Graph pooling reduces the graph size while maintaining crucial information. Question 16. What is a common disadvantage of GNNs? A. Inability to handle heterogeneous data. B. Their tendency to over-smooth node features. C. High computational cost for large graphs. D. Over-reliance on handcrafted features. The correct answer is C. High computational cost for large graphs. Large graph processing requires significant computational resources. Question 17. Which of the following architectures is used in GNNs? A. Convolutional layers. B. Recurrent layers. C. Fully connected layers. D. Attention mechanisms. The correct answer is A. Convolutional layers. GNNs utilize graph convolutional layers for node feature aggregation. Question 18. What is a common use case for graph neural networks? A. Predicting house prices from numerical data. B. Classifying social network users. C. Image segmentation for medical data. D. Time series forecasting. The correct answer is B. Classifying social network users. GNNs are often used in analyzing and classifying social networks. Question 19. Which of these is a limitation of traditional GNNs? A. High computational complexity with large graphs. B. Inability to handle any form of graph data. C. Dependence on pre-processing and feature extraction. D. Overfitting to small graphs. The correct answer is A. High computational complexity with large graphs. GNNs face challenges in scaling to very large graphs. Question 20. What is the goal of a graph convolutional network? A. To perform node classification. B. To segment nodes into clusters. C. To propagate node features through the graph. D. To reduce the graph size. The correct answer is C. To propagate node features through the graph. GCNs propagate node features through the graph to update node representations.